All right, so week two, we are going to actually get to dive into um, how we actually query our database or pull data out, which I'm actually really glad that we kind of go about it because previously in the course, we actually would start creating a database rather than learning how to use it, which is both good and bad. But it seems like in databases, it's always kind of a little bit of a catch 22, which you'll find a little bit because like we're going to start with learning how to select data, and we're going to do it in a great way where hopefully we avoid the catch 22. But really to understand how to pull the data, you got to understand like how it's put in and yada yada. But the good news is with selecting data, what I always tell people is that it may not make 100% sense yet, or you may not understand it at a very fundamental level, but that's okay because we're going to kind of come back to it. In fact, in the course, if we look at the modules, actually, we end up revisiting a lot of content. So, for example, week 2 is query primer. Then we go into filtering. Then in week 4, we query multiple tables, which is a join. And then we go into sets. Data generation, manipulation, and conversion is more select statements. Grouping and aggregates is more select statements. But then, in week 9, we actually start regurgitating some stuff. So in week 9, we actually go back to our joins, which is basically a regurgitation of week 4, which is multiple tables. So we kind of go more in depth. And then in week 10, we do more filtering with conditional logic and so on and so forth. So we may not understand everything yet, but we're going to just kind of take it step by step, and hopefully we never get stuck in like a catch 22. So anyways, let's just take a real quick look at the goals for week 2, because I think it actually kind of helps segue into what we kind of want to do. So basically this week we are focusing mainly on select statements. And with a couple additional things. So the select statement is how we pull data from our database, basically how we say like, oh, I want to see certain information back out. It's the whole reason we put the data in to begin with. So the select statement is kind of the bread and butter of the SQL language. But there's a lot of components to it. And so this is kind of like a really good introduction that's going to catch up to speed. Now, if you haven't already, I hope they're good. So I'm not going to say you should, because I actually haven't gotten any feedback on it yet. But I have these quick bite videos that I sent out in the announcement. You should take a watch on those if you kind of want like a quick, like each video is under 5 minutes long, and they kind of go through a lot of these different components. But we're going to go over him here today. So for those of you who are here, you can watch those, or you don't need to, because you're going to be here for it. But if you want like a quick refresher, they'll be there. So anyways, we're going to go over each component of the select statement, which we'll go over. But just a couple other quick housekeeping items. Wanted to go over a couple of these additional things. So additionally, under the reading assignments, you'll see stuff about relational database models, yada, yada. And then additionally, our paper this week is actually replaced by like a little offshoot project where you're actually going to reverse engineer a website. And I'm going to kind of walk through an example of that here in just a little bit. And it's a perfect precursor for the final project, which I will kind of hint at today just a little bit. So real quick, basically agenda of what we're going to do here tonight is I'm going to go over the select statement real fast, talk about each one of the proponents, the order that they run, and then we're going to talk a little bit about the task you have for week 2, and then kind of tease into final project. So yeah, let's just dive in because don't want to take too much time, and there's a lot of ground to cover yet. And I think I referenced it in the announcement if you want a link, but on Michael McLaughlin's website, which he is the person who kind of is the author of many things. In fact, our old books, he wrote for Oracle Press for a while. Professor at BYU Idaho, he was kind of like my mentor when I went to school, so I gravitate toward his content because it's really good. But he has this page on the select statement that I think is one of the best breakdowns of a select statement that I've found. Because the first part of a select statement, or an important part of the select statement, is understanding the order in which it's run or it executes. Because the computer is going to do it. And to me, it's completely logical, which is what I love. It just makes sense. So that's what we're going to kind of go through. So I'm actually going to let's pull up a workbench here while we're doing it. And we can kind of play around while we're having fun here. And let's try again. There we go. Okay. All right, let's open up a new query here. Not a new model. That's not what we really wanted. We just want a new SQL file. Okay. So select statements, they can be very simple. So I'm going to start off with the customer data. So the most basic select statement you can kind of have is, well, really the most basic one you can have is you can really select just a string literal from nothing. So, you know, I can actually just select something from nothing. But as far as when we're selecting data from a table, I always kind of start with this. I say select everything. The asterisk is for everything, all the columns from customer. So basically I have no where clause. I am selecting all the columns. So basically dump it all to me. And that's kind of like where I like to start, at least in the context of these few rows. Now, normally if you're in a production database and there's a million rows, you might want to limit it, you know, because we can actually say like, you know, limit 100 where we get like the top 100 or the first 100 rows. So like we can say limit 100 and bam. So now we're limited to, notice this one we got 600 rows, this one we got 100 because I pulled it to limit it. So that's kind of where I like to start. And the reason I like to do that is because we can see all of our columns with some contextual data, which is really important because we kind of want to see the data type. And additionally, sometimes I also like to just pull up a terminal. Oh, and I typoed again. I like to pull up a terminal just so it use Sequila, and like, for example, I can describe customer because like I can pull it up, but honestly, I kind of prefer this view because it's just more compact. Like I can go here, go to customer and go to columns here, but you'll notice it doesn't show me the data type, and otherwise I have to pull up a whole other tab. And so a lot of times I like to keep these things like, you know, I have two monitors, so I'll keep this one kind of tucked away over here because this lets me see the data types. And then both of these views combined really lets me kind of understand what's going on here. So I can look at this and say like, oh, you know, add integers, strings, and dates, you know, pretty easy to, or timestamps, pretty easy to see. So the simplest one, select everything from customer. Now I'm going to start and we're going to build on as we add each clause. So the order in which this runs is, even though the select comes first, it actually starts in the from clause. That's always the first thing it does. And it makes sense, right? So I always like to make the analogy of, you know, getting data out of a database is really the same logical steps that we would take every day if we wanted to, you know, if we had a whole wall of filing cabinets, sorry, couldn't think of the word. If we had a whole wall of filing cabinets and we needed to get a single folder from somewhere in those filing cabinets, it's almost the same logic that we would take, right? So step one is we need to know where we're getting our data from. So let's say that our filing cabinets are numbered. You know, we have a file, or, you know, labeled. Let's say we have a filing cabinet for invoices and we have a filing cabinet for customers. You know, I would want to go to the customer filing cabinet. There's no need for me to go to the invoice cabinet. So that's the reason it starts there, is because we need to know where we're getting our data from. That's step one. And I'm going to refer back to this website pretty frequently. And so if we have our basic select statement here, the first thing that runs is the from clause. And then finally, the last step always is it just says, hey, these are the columns you show. Because even though we're only, we could select, first name here, even though we're only seeing the first name, all that data is actually still back somewhere. The select list just tells us which one actually just shows at the end of the process. So if we have select and from, the from clause runs first and the select clause is final. All right, let's now add a filter. So let's say we want to filter this down. Right, in honor of Betty White. So if we want to filter down our customers, we add a where clause. And we want it to where the last name is equal to White for Betty White. So in this case, same order of operations here. This is going to run first because we want to know where we're getting our data from. The next thing we want to do is identify like what we're looking for. So let's say we have our filing cabinet there for customers. We go to the customer filing cabinet, that's step one. And then let's say there's 3 drawers and each drawer is a section of the alphabet. Well, if we're looking for Betty White, there's no need to rummage through the A through H bin and the I through M bin. We just want to start right with the N through Z bin, right? And so that's why we run the where clause, because databases need to be efficient. Because in our case, we're only dealing with 600 rows, but in someone like Facebook, Google, you're dealing with a massive amount of data. And every time we run a query, we're going to load that information into the memory of the server or the computer. So we want it to be extremely efficient and fast. And so we want to make this as efficient as possible, or they have rather. So the where clause can help filter it down because we know where it is. We can limit down to a certain section of the data. And then that way, instead of dealing with 1 million rows, we're dealing with, 100,000, right? So that's kind of like a way to think about it. And then finally, our select list runs. That's always kind of the last step. So let's add another step here. If we have an order by, and I'm going to change this where last name is like W. Basically, does it start with a W? And here's all of our information here. And I'm going to add last name so we can see the result there. There we go. So now I have all of our customers whose last name starts with a W. But we want to order this, and I'm going to order by last name and then first name. There we go. So now we have last name, first name, order, and there we go. So as far as ordering now, it goes the from clause, the where clause, and then it's going to order it before it shows it. So the order by is really just kind of like another, just like the select list, it's kind of just like for showmanship. So those always kind of come last step. All right, so now we're going to get a little bit more crazy here. So what we're going to do is I'm going to actually select, let's do this. Let's select the substring of last name. Yeah, this works. There we go. Perfect. So basically I'm going to get the, and I don't expect you to know how to do this. I'm just trying to add an element that will let us use like each one of these clauses. So basically what this little section is going to do is it's going to pull the first letter of someone's last name, right? So I use this substring function, which we will cover in a future week, and it's going to pull the last letter of someone's name. And so basically what I'm going to do is I'm going to get how many people have each letter, the last, how many people are in the letter of the alphabet by last name. So I'm going to get the count of customer ID. So we'll just do name count as that. All right. So in order to do this, because basically what I want to see is I want to see like A has 20, B has 10, C has 15, yada, yada, yada. And to do that, we're performing what's called an aggregation. And apologies if some of you guys have already seen this in CIT111, but I just go over it as if you'd never heard of it. But this is called an aggregate function, meaning we're going to take multiple rows. So for example, let's just take a look, select everything from customer, order by last name. Right. So if I was going to take a look at this, you know, I can kind of guess here. So there is 20 people with the last name of A. Wow, that was a good guess on my part when I was kind of throwing in those fake numbers. But there's 20 people with the last name that starts with an A. And the reason it's called aggregate is because we're going to take all 20 of these rows and compress it into a single row. We're going to take many things and summarize it into a single thing. And that's pretty much the definition of aggregate. So we're going to use an aggregate function, which is the count function, because it's just going to count how many customer IDs there are, which are unique. So we'll get a unique count of people. And we're going to do it by the last letter of the name. But there's something we need to do to tell the computer how to do it. And again, this is just an introduction. We're going to cover this in a later week. So this is solely just so we can see a whole select statement. I'm going to tell it to group by last letter. All right. And then because I no longer have last name, first name in my list of things that I'm going to show, I'm going to change my order by to be the last letter. And there we go. And again, I'm filtering this. So basically where it's W. So let's just take this out for right now, just so we can see like the whole result set, right? And bam, there we go. So this is all of our counts of people by the first letter of their last name. So in this case, what's going to happen is it's going to, let's leave that out just so we can see what happens. So it's going to run the from clause first, then it's going to run the group by, then the order by, and then the select list. If I had the where clause, so let's say we just want to exclude Z, because I don't think there are any anyways. So if I exclude Z, basically it's the same order of operations, just we're going to keep the where clause in there. So the from clause will run first. The where clause is going to filter it down so we don't have to deal with as much data. Then the group by is going to run so we can compress even further. But it wouldn't do any good to compress before we filter, because then we'd have to recompress. So that's kind of like how like I said, keeping it logical. So we find our data, we filter it down so we don't have to deal with as many folders or data, and then we compress it down. And then lastly, we order it and then decide what we want to show. All right, we're almost there. We're almost there. We have one more clause that we got to do. We're going to keep it. We're going to keep it here. So now let's say there's an additional clause called the having clause. And basically the way I like to think of the having clause is it's a where clause for the group by. So let's say that we have our list of letters, right? But let's say I only want to see the ones that have less than 10, right? Like, what are our rarest last names? If I put it up here in the where clause and name count is less than 10, right? If I try to run this, it's actually going to fail. And the reason being is because let's think of our order of operations. We're going to run the from clause, the where clause. Next, we haven't grouped by yet. So we have no way to filter on it because it hasn't happened yet. So that's why we have another clause for all of our aggregates. So if you have an aggregate, basically something that happens after the group by, we put having, and that's kind of our filter. So we say having a last letter, or a name count, sorry, having a name count that is less than 10. And there we go. So now we have a list of our letters that have less than 10 people in that grouping. Everyone following along so far?
I got it.
Cool. And like I said, you don't need to know how to do it yet. It really just is like, if you can remember what each one of these do, that's great. And then order of operations can help you tremendously when you're trying to figure out like, okay, like what is this query doing? So basically the way it works is pretty simple. If you have a full query, basically start at the from clause, go down, and then go back up here. So it's pretty easy to remember. Start at the from clause, go down, and then lastly, look at what columns to show. All right, cool. So that's that. That is a full select statement. That's pretty much that's all the clauses in one. So, I mean, they can definitely get more complex, but yeah, that's it. As we can see here, there's joins that we can do, but those are technically part of the from clause. All right, so that's that. Let's go back to our game plan here. So now we're going to talk, I guess I'll pause there. Does anyone have any questions about select statements or anything they'd like to see? Anyone need some clarifications?
So when we are creating these select statements, does the order happen automatically? Like if we screwed up and put the group by above the where, is it going to run the like it's supposed to anyway? Or we just need to make sure that we have them ordered in the specific, just how you've done it here?
Yeah, so actually, yeah, so this, good question. This is actually the structure that has to be there. So if I moved one of these above the where clause, it actually isn't going to run. It'll get mad at you and not work.
It'll give you an error though. It's not like it's going to run and just miss that line or whatever.
Correct. Yep. It will actually give you an error. So like, in fact, you can already see it right there.
Okay. Yeah.
Yep. So yeah, but it'll throw an error. And like I said, you can kind of mix these, and it's nice that it runs in a similar order to what it's written, which is kind of the point. That's one of the things about SQL. If you didn't, I can't remember if it's in the book or not. It's been a while since I've reread the first few chapters, but SQL was originally written for business people. And so the idea behind it was, hey, like, let's make it kind of sound like English. Like, oh, I want this from this, where this is like this, and yada, yada, which, I mean, we all know a lot of business people, and, it's kind of funny that was what they thought, but, kudos to them. But the nice thing is it makes sense. The more you use it, it'll make sense. So the way it executes is similar to how it's written, which is really nice. The only caveat to that is the select statement is a little weird, but whatever. Because like really what would be nice is if this was like select, but then down here we choose like what would be nice is if I was to design this, I'd say like select from customer where, and then these are the columns you want to show or something like that. But anyways, not the case. So yeah, you always, if you have all of them, they have to go in this order. And it's also similar to the order that it executes in. Good question though. Okay. While I'm pulling, oh, yep, go for it.
So forgive me if I'm missing something. I have read a lot of things in the last 2 weeks. Have you provided that website that you were referring to? Is there a link for that we can look at?
Yes, it is in the announcement for the week.
For this week?
Yep.
Okay, thank you.
Yep. And just by way of, I guess, saying it, so they provide, because basically the course is, pre-made for the most part. So basically I use the announcements as kind of like my way of, I like to share some of like my own like personal, like, oh, this is a really nice resource in the announcement. So if you're ever looking for that kind of stuff, that's where I like to throw it. Okay. So let's take a look at the reverse engineer a website database. And I think, and I guess we should back up a little bit. There's what's called an ERD, which is a relational database model. I don't want to watch the video. So I'll just show you how, and I know some of you have already done this because you have you put them in your paper. But in Workbench, if you go under the database column, there's a little option to reverse engineer, which is really cool. And what we can do is we can actually build an ERD off of an existing database. You can also build a database using it, but that's not what we're going to do. So let's take a look at Sequila here. And we can go ahead and just run this and we are good. So this is an ERD, and it stands for Entity Relationship Diagram. Because what it allows someone to do at very quick glance is see the schema of a database. Very easy. So these are actually pretty popular. So like whenever I'm consulting and need to do like ETL work or similar, I always have them send me an ERD, because in that way I can go through and see like how everything's connected and see where I pull my data from and kind of like what it means to a certain extent, because sometimes it can be a little ambiguous. So in the last week's paper, kind of had, or chapters and paper, it talked about relationships. And I noticed a lot of you in the paper talked about primary key and foreign keys. So there is which we'll talk a lot more in week 4 when we go over joins, because that's really where they become important. But just for context of seeing how these connect, because I always got asked, well, in the business world, people always like get confused between Excel and a database and yada yada. So this is a good example. So, if we in a spreadsheet wanted to track people's emails, it could get cumbersome, like, because if we have like a name and, we might have email 1, 2, and 3, but what if they have email 4 and 5? So basically what we do in a database is we split those out into 2 tables, a person and an email table. The person holds the person's name and the email would hold the email. And then we have a connector between the 2. So if we were to look at this, we have a primary key is the column that uniquely identifies a row. And usually they just count up from a given number. So for example, in the person table, we just count up, and then the same thing in the email table. The email ID is just to count up. And because the reason we have those is because there can only be one of those in the table. So person ID 2 is always going to be myself, whereas person ID 6 is always going to be Aragorn. We don't ever deviate kind of from that. There can never be another person ID 6 in there. And so we use those primary keys in another table. So that's kind of why it's foreign, because person ID belongs in the person table, right? And so we put the person ID is the primary key in the person table, but we also put it in the email table. And that, if we're in the perfect design, those kind of situations should be the only primary keys, and foreign keys should be the only data redundancy that exists. Just like we're not going to put first name in the email table, because that way if someone changes their name, we're going to have to update that in 2 tables. We're going to have to make sure we keep everything matching. And so if we do proper design, we should never have a value that exists more than once, for a single thing. So that's a primary key in the table where it's it belongs to. But when we're connecting it, so like, what person does this email belong to? It's the foreign key. because it's foreign. It doesn't belong there. So taking that back to here, every one of these lines represent a primary and foreign key relationship. And we can kind of look at it just like in our little situation here. If we were to kind of design this, a person can have many emails, right? But an email can only exist to one person, because in email we have person ID. So a single line on the email table is attached to a single person ID, but the person can be attached to multiple emails. So that's called a one-to-many relationship. A single person can have many emails. So that's why we call that a one-to-many relationship. And so as we look at these little lines, you can see these this little thing that looks like a caret foot. That's usually what they call it. And that denotes a one-to-many, the caret foot being the many side relationship. So like, for example, if we take a look at this, let's pull this over here where it makes a little bit more sense. So if I'm looking at this line here, we can see that a single customer, a store has many customers, but a customer can only be tied to a single store. So what's important about this is whoever designed this database has to make choices. The way we design our database has real business implications. And this is probably my favorite part about database design is thinking through all these implications. So in this case, let's say that we have a customer who has a house in St. George, and as well as a house in Idaho, right? And let's say that this movie store, he wants to be able to use the Blockbuster in Idaho as well as the Blockbuster in St. George, depending on where he's at. In this case, well, we're going to have a problem because a customer can only belong to one store. Now, maybe this denotes that's like their home store. I don't know if it'll stop them from ordering. In this case, it actually would. So there is going to be a problem here. But depending on the situation, you're going to have real business implications. Because if all of a sudden he shows up in St. George and says, I want to rent this movie, the cashier is going to be like, well, it won't let me create you because you already exist and you're tied to the store in Idaho, and yada, yada. So I'm sure we've all kind of been in situations like that where we're on with customer support and something's not working. Odds are it's because someone didn't think of an implication on the database side. So anyways, as we're thinking about this, the task for the week is to reverse engineer a website. And it says a website, but you can really do anything. In fact, if you just like want to plan, well, really we should reverse engineer one. If you have like something like whether it's a game, a website, a product that you think would be good to reverse engineer, great. That's what we're going to do. So I'm actually going to walk through that. But real quick, before I start walking through it, does anyone have any, and don't be afraid to say so, did I completely lose anybody? Or does anyone have any questions up to this point? And it's okay if you don't 100% get this, because we're going to go over it some more, but just want to make sure that I haven't completely lost anyone. Okay, cool. So reverse engineering a website. So basically what we're going to do is we're actually, like I said, we're going to make an ERD. So you can pick anything you want. In this case, I'm going to do a store, and this is actually my mom's e-commerce site. She makes soaps that are actually they're the only soap that I like the smell of, because I'm not big on like the bath bodywork type scents. But anyways, I'm going to kind of reverse engineer how this works. And I'm sure you guys have heard of like WordPress, WooCommerce. A lot of like these people run their little e-commerce sites on them. And we're going to reverse engineer it. Not saying that we're going to be right. It doesn't have to be right. Really, this is an exercise in just trying to wrap our heads around how might this work. And so that's what I'm going to do. I'm actually going to reverse engineer this the best I can. So I'm going to leave this up here. I'm going to make this really small. Actually, let's go take a look at the instructions real fast before I get too carried away here. Modules, what am I looking for? All right, week 2, reverse engineering website. All right, so we're going to all right, so we're going to read the case study below, write a 5-10 minute video presentation, and submit the report. And also, just so you know, this says provide a web URL rather than upload the video. That's absolutely correct. One thing that's always a problem is people record it with Zoom, but it's private. And so like, I can't ever get into it unless you give me a password, yada, yada. And honestly, I don't know what it's like to record on Zoom. So just keep that in mind. If you're recording with Zoom and hosting, like if you record to the Zoom cloud, make sure you unlock it or try the thing. And you can record however you want. I use a program called Peak or OBS Studio. You can put it wherever you want, whether it's on YouTube or whatever. Just make sure that it's accessible to myself. So that way, really, it just needs to be open. And like I know YouTube does like you have to have a link. It can be unlisted, but you have to have a link because especially through Canvas, it gets weird when I have to, because even if you add my email, it's really in Canvas. Anyways, it gets weird. So if you can just make it public, that's best. And don't worry, like if it doesn't work, I just reach out to you. It's not like you just automatically get a 0 and you're done. So no worries. Don't stress about it. Just something to keep in mind. All right. And I have actually never tried Loom, but if it works, that's great. I use Peak, which is really nice. I don't know if it's available outside of Linux, but that's usually what I use. Or OBS. In fact, I think for most of my stuff, I use OBS. Okay, so the case study, and you can kind of ignore this kind of stuff. It's kind of just like for fun. You can choose to role play with it if you want, but either way. But you should pick a website that isn't too complex and attempt to reverse engineer the design. You should complete either a spreadsheet breakdown that you can later implement in an entity relationship diagram or a MySQL Workbench ERD. And I'm going to tell you straight up right now, it's easier just to do the ERD. So that's what I would recommend. I'm not saying you have to, but it is easier. And it says you should return a report with a Zoom video, whatever kind of video you want that demonstrates your design and approach you took to create it. And you should be walking us through your design process. I actually don't care if I see your face in the video. It's for like, so there's not copywriting. So if you want, like you can show a picture of yourself, but I'm one of those types of people that I don't like to show my face while I record because I probably make weird faces. So if you don't want to show your face, absolutely cool. The presentation should be somewhere between 5 and 10 minutes in length. And again, really it's just about walking through it. So let's go ahead and start with this. So I'm actually going to create a new model. So I'm going to go to Workbench. I'm going to say File, and I'm going to say New Model. I'm not going to save this one. Here we go. And you'll hit this screen, and I'm just going to click this Add Diagram. And bam, here we are. We are ready to rock and roll. So I'm just going to start doing this. So let's take a look here at my soaps. And so like a lot of this is going to be guessing, and that's completely okay. So what I would say start off is kind of explore just a little bit, and hopefully it's maybe something you're already familiar with. So if I look at this, I can kind of make some inferences. So initially there's some product, and that's actually where I'm going to start. I always like to kind of start at a root somewhat level. Let's add a new table. So I can click here and click here. You click the button and click where you want to put it. Then you can double click on it, and I'm going to give it a new name, and I'm going to call this a product. And inside the product table, the first thing we need is a primary key, product ID. And I'm going to check these and I'll explain those just so we know what's going on. So we choose a data type, which in this case is an integer. It's primary key, not null, and auto increment. I don't care about this. Really doesn't matter too much. That's just what I'm going to do there. Just so it's ready for whatever. Then I'm going to add a name, varchar, and this is where we get to choose length. A character string, let's say it can be up to 60 characters long. And obviously we don't want that to be empty, so I'm going to hit the not null there. All right. Now, again, like I said, we got to think of some business implications, right? So I think like back when I was starting, it might be easy to say, oh, a product has a price, you know, and we throw a price here, like a decimal 15.2, so it's a price. And there we go. And so like we have a price there, but really what we want is to be a little bit more dynamic. So again, just thinking about this, what if we have a sale and we want to change the price? Well, we could just update the price, but we want to keep a running list of, you know, what our prices were at given times. And in case the IRS ever comes and audits us, we want a record that says, no, I put this on sale at this time, or I adjusted my price. So what I'm actually going to do is I'm going to build another table called a product price. Sorry, I capitalized this. There's some data systems like Microsoft SQL Server likes uppercase. MySQL is kind of like lowercase is the preference. I'm going to call this a price ID. And in fact, let's just call it a price just to simplify this down for the sake of making it easy. I'm just going to call it price. Price ID is an integer, primary key, auto increment. And I'm going to give it a product ID that matches to the integer column. And then I'm going to give it a start date. And an end date. Now, if we wanted to really be granular, we'd give it a timestamp, but I like to just keep things simple. So sales just go by dates. And then finally, we are going to have which again is another business decision that I'm making right now. Let's say your boss says, hey, we're having a sale that starts at 5 o'clock on this day. And you say, well, when I built the database, it only has dates. So you have to start on a specific day, and he gets mad, you know, whatever. So that's the things you got to think through while we're doing it. I'm just going to put dates for simplicity. And then finally, we actually want a price. And common money format is 15.2. And that's going to be not null. All right. So now if we're ready to connect these, what I do is on this tab, there's this foreign keys tab. I'm going to click here. And technically, is there a way to add a connection? Yes, we can just build this out. So for simplicity right now, we are going to place a relationship. Pick one or more columns for the foreign key. So I'm going to pick product ID and product ID. Easy enough. So that's pretty slick. And I know it's hard to see. I apologize. There is a couple buttons here where we can pick a one-to-one or a one-to-many or many-to-many or a one-to-many relationship, which is what we did, because a product can have many prices, but a price belongs to a product. Does that make sense to everybody what we just did right there? Or better question, does it not make sense to somebody?
Yes. How did you link it to the price, like, I don't know if it's your resolution or mine, but everything's really small, so I'm having a hard time seeing it. But is that the, in that price box, how did you get it to link to that one specifically and make that the foreign key?
Yeah, so I'll go through that process again because there's a tab there that you can define it manually, or we can kind of use the UI. So I'm actually going to delete this. Let's delete the foreign key. So let's just go through that process again. So again, apologize, there's small buttons over here, but I'm going to choose the one-to-many relationship, which is a line with a chicken foot. I'm going to click that. And then you can just click anywhere on here. So I'm just going to click right here, maybe. Oh, that is not what I wanted. I'm not sure what it's doing now. Delete it. Okay. If I click here and do I need to drag it? No. I'm not sure what happened. Non-identifying relationship. Identifying relationship.
I was thinking in the video you had to select one of the items. Yeah, like if you selected there and then clicked on the other one. Maybe I'm thinking of something else.
No, I think that's right. Yep, I think that's right. It's just a little backwards. So what we
You
want
have
to
to
do,
pick the mini one first.
yep. So we'll start with the foreign key first, if that makes sense. So in the price table, and oh, and you know what I did, why it's not working the way it should, is I actually it deleted my column for me, if that makes sense. So if we look here, there's not a product ID anymore because I told it to delete it. So I'm just going to pop it back in here, change it to an int, and it looks like it'll make it for you if you want. But I'm kind of stickler about seeing things the way that they should be. Okay, so if I select the foreign key, so I want product ID and I want to connect it here. There we go. That'll work. And I really don't care if it's the dashed line or the other line. It doesn't matter to me because really this is just like an exercise in building the diagram. So anyways, we'll click the other one and then there. So now what I'm going to do real quick is I'm actually going to the columns used by the foreign key should. So I'm going to do that. So what I'm going to do is I'm going to show you how to do this manually here. Whichever way you like, but like that's kind of finicky for me. So I just assume do it manually. So I'm going to click on the foreign keys tab and basically just going to double click here. It'll auto name it. And I'm going to tell it what it wants to reference. So in this case, what I'm going to do is I'm going to say, I want to reference product and product ID. So you can see how that kind of like built it here for me. That's usually how I go about it is, so just to walk through that again, I'm going to delete it and start over. So I'm going to delete. So you'll go to the foreign keys column, just double click in here. It'll auto name it. You tell it what you want to reference to. So since I'm in the price table, I want this product ID that's foreign to reference the primary key of product. So I say reference product, and inside the product table, you're supposed to be looking at the product ID column. And there we go. There's some additional options that we could do there, but we'll wait for when we cover it. So there's that. Perfect. Everyone good there? Know how to kind of build the lines? You can either build them by clicking or you can build them through the menu, up to you. Completely up to you. All right, so let's take a look here. So the other thing, so that'll handle the price here. The other thing that I'm noticing is that there are like categories, right? So there's like the foaming soaps, but there's also like a gift box, it looks like, or some different categories of things. So we want a way to have categories. So let's add another table. I'm going to call this product, or we can just call it a category. Let's just call it a category. I'm getting ahead of myself. Just going to keep this simple. Category underscore ID. It's an integer auto increment. A category is going to have a name. Bar chart. We're going to let it be bigger. We'll say up to 160. And I'm also going to give it an active field, which will basically let you turn them off. I'm going to do that as an int, not null. The default is 1. You don't have to do that if you don't want to. I'm just habitually doing this. Okay, so there's category. Now, what's interesting is this will be another design step here. A product could probably exist in multiple categories. Oh, and Brent, I just saw your question. We will only be using solid lines. Really, the solid line is the wrong one. I think you want the dashed one to be correct, but in this case, I don't matter because we're actually not building it. It's really just to see the relationships. So dashed or dotted doesn't matter to me, whichever you get used to, but technically the dashed, but it's not going to do anything wrong. But in this case, we're going to have a design step here where I want to make sure that a product can exist in multiple categories all at the same time. So what I'm going to do is I'm going to create a middleman table here that's called product category. Product category ID. And when you do this, there's a way to kind of like, you'll see it like in some of the other stuff, it like is like product underscore has underscore category. To me, that is really weird. Like you never see that in real life. So usually it's like if there's like a table between two, it's usually like table underscore table or something else that's technically correct. So in this case, it's like it's a product and a category combined. So I'm going to start off by saying, oh, I want to connect this to product because we want to know which product is here that we're talking about. And it's not null. And then we also want to tell it what category it's in. And it's an integer and also not null. So we'll just let this be. We're not going to historically track this or anything like that. We're just going to basically rearrange stuff in real time. So again, I'm going to build the foreign key this way. Actually, I'll do both ways. So let's connect this to product this way. So product ID is connected, right? There we go. And I'm going to try and connect this one like this. So we're going to say, click here. We start with the foreign key is here. Then we go to the category. There we go. All right, so now we kind of have like this big kind of circular thing going on here, right? Where we have products and those products can be in multiple categories and a category can be assigned to multiple products. Everyone following along thus far?
Can I ask a question real quick?
Yep, sure.
When you put that linking thing from category to product category, then it created a new foreign key called category underscore ID.
Yes, I'm glad you brought that up. So that's why I usually just do it manually. So technically, because this is kind of built so you could do it all through the menu. So technically, like if I wanted to, like let's delete this one. It's built so you can kind of just like do it all. So I could just go like this and there it is. And then then I could bump in here and just rename this. The reason it gave it 2 categories is because I think it says table underscore column, if that makes sense. But yeah, you can rename it at will.
Okay, it also has the product category ID too, in that product category table.
Yes, good call. Let's delete that as well. There we go. And that one I had connected manually, so we should be good there. Thank you for bringing that up. Awesome. Okay, so now we have this. So the last thing I'm going to do is I'm going to build a way for people to order stuff, which can get really complicated. So I'm going to keep it somewhat simple. So basically I'm going to have an order. Basically I'm going to pretend that we're not like tracking users or anything like that. So an order ID, primary key, auto increment. Also going to have a so what do we want with an order? An email of our customer, right? That's probably important. We probably want the date that it was ordered. So I'm going to say date ordered. Actually, we'll do a time one. Time placed. When was the order placed? And this is a date time. Gonna make it so it defaults to current timestamp because that's one less thing that the programmers have to track and keep track of. So we have our date time. Let's see. What other things? Let's do. We're going to circle back to this. So I'm going to leave that just like that for right now because we need to build a couple supplemental tables. So the first thing I'm going to do is I'm going to add an address table. And our address table is going to be where we can kind of store addressing information. And addressing can be difficult to say the least. So what we're going to do is just keep it simple again. And I'm just going to say address line 1. I'm going to do an address line. Or let's do this. Let's do street. And technically this would usually all be in different tables. So our street, we're going to let you have up to 60 characters for your street. Technically we can just call this line 1. We'll just call it line 1. That way it makes sense. Because really, if we were doing this, we'd have like a table with zip codes and cities and all that kind of fun stuff. But just to keep it as simple as we can, I'm just going to say we're US only. So I'm going to have a state table that has a state ID, primary key, auto increment, a name. I think no states go over 45, and abbreviation is always nice to have. I like to have an abbreviation column in our table. And I think technically, as far as abbreviation goes, we need 3. Maybe it's just 2. I'm not sure. We'll put 3 just to be safe. And then finally, we need so we have a name and abbreviation. I'm going to put active because maybe we don't ship to all 50 states and we want a way to turn that off. So I'm going to put int not null. We're going to set the default to 1. There we go. So we have the state table, and that'll basically hold all the states and their information. So now back in our address table, we want to add, because we have line 1, line 2, and then we're going to do city, a state ID, because we don't want people typoing the state, right? Like, what if people put, and that's what this allows us to do. So that way they're not like abbreviating, like for example, Wyoming, do they type out Wyoming? Do they type out Wyoming all caps? Do they type out WYO? Do they type WY all lowercase? Because when we're trying to aggregate information, like say, oh, how many orders do we have in Wyoming? We don't want to have to try to worry about 100 different versions of the same stuff. That's why technically city would be a good thing to have, not as something that the customer enters themselves, but rather, or zip code, because really we don't worry so much about city, but yeah, that's something that we usually let customers not put in, because it's super important, obviously, that it's consistent across everybody. Okay, so we're just going to leave that just like that. We have state ID, so let's connect those two. So since I defined it, we'll just go here, address, and it references state, and it references the state ID. There we go. All right, so there's our address. And the other thing I'm going to do is I am going to, actually, let's just leave it just like that. So back to our order table. Let's delete this. Back to our order table. When someone makes an order, we have their email, the time it was placed. We want a shipping address, but we're going to tie it to an ID. Because we're going to tie it to that address table. And then we want a billing address ID, right? And what's cool is we can use the same structure to hold both of those. So this is going to be kind of fun here, actually. So as we build these relationships, so let's start off with the first one. We are going to reference address, and we're going to say shipping address. And then the second one is going to do the same thing, but it's going to reference the billing address, both referencing address ID. Oh, wow. And those are right on top of each other. Anyways, that's what it is. They just like to cross for some reason. Can I move you or you connect? Nope. Okay, it's just going to be a little weird. But anyways, this line, so a single address. So for example, if I get mail at my house, at my single address, that's also my billing address, these two numbers would be the same. You know, so let's say I placed an order. My email is fake@fake.com. I placed it at 1907. You know, January 12th, 1907. And then shipping address is 1, billing address is 1. Let's say I'm the first customer and I only put in one address. Those are linked to the same address. But if I have two, like my PO box and my stuff, there's two in there. All right. And then let's see. To do a many-to-many. Right, I'm seeing your messages, but I'm not quite following.
So you were trying to make a many-to-many relationship between order and address, right?
No, not necessarily. Basically,
Oh, my
yeah,
bad. I
'cause
was misunderstanding it. Okay.
yeah, many-to-many relationships are going to be used very rarely. They can be very messy. Many-to-many relationships will probably rarely be used because they get very difficult to keep first normal form. But the reason I did this is because an order, we don't necessarily care if an order belongs to an address. We only care what address is attached to the order, if that makes sense.
Okay.
So these are one-to-one relationships, meaning that an address can be attached to multiple orders, right? If that makes sense. And by proxy, many orders can be attached to an address. But we don't necessarily want a many-to-many relationship because then ownership gets strange. So for the most part, I would say I would say stay away from many-to-many relationships because they can be difficult to understand. Basically, you have to have keys in both tables, if that makes sense. So we'd have to have order ID in address. If we were going to do a many-to-many, address table would have an order ID, and we would have a ton of redundant data, if that makes sense. Because then every time someone inserts an order, they would have to, we couldn't repurpose addresses, if that makes sense. Okay, let's see here. So we have that. Address is all connected. We have the billing and the shipping address, both connected to address ID. So let's polish this off here. So the last thing we need is we need to connect what they bought in their order. So again, we're going to create a table here. I'm going to call it order product. Order, I always like to kind of get somewhat consistent. This table is just going to be a bunch of keys, essentially. And really what it's going to allow us to do is it's going to let us connect all this together with historical context. So what I'm going to do is in this, I'm going to connect the obvious ones. So let's go to foreign key. Let's go ahead and add our foreign key to order. And then we're going to add our foreign key to product. And then we're going to add a foreign key to price. And the price one is probably the one that's going to throw people off the most. And technically this is not absolutely necessary, but I'll tell you why it's nice. So the reason why I chose to do that is because that way it's really all about convenience. Because technically we could go this way. So like if I was going to write a query and say, okay, you know, this is the person's order and how much did they pay? Oh, and I forgot some stuff. So how much did they pay for the Sage hand soap or something like that? You know, we could go back and look and say, oh, well, they ordered at, you know, on January 12th. So what was the price on January 12th? We could do that, but it's not as efficient to the system, especially where these are kind of disconnected because our order system is going to pull the price at the time of purchase to put in this table. So it's just a little faster. So basically when I make this order, it's going to say, oh, you know, put this in the cart. What's the current price? Bam. There's the current price based on the time of the order because the end date will be null, if that makes sense. So basically that is kind of it. I think the only thing that I would change a little bit here, which I'm going to do, is I forgot to add one thing that I always like to do is in our state table, and this is another reason why we separate things because it makes it a lot easier to add things after the fact. We might want to add a tax rate to our state. Make it a decimal 15.2. We're going to say the default is 0.0%, which we know isn't true. But so now what we can do is we can say shipping amount and order total. Now we can track how much they paid for shipping, how much they paid for tax, how much they paid for everything involved, yada, yada, and then the order total. Now I'm obviously missing some components, like for example, like a transit, like we'll have the order, but maybe we want to track like how they paid, did they pay by this way? But most like little small mom and pop shops don't actually keep that on their system. They run it through somewhere else. So, maybe this is like, here's a good little another one, Square transaction ID, right? So maybe we want to connect to a third-party system and track that. So later we can connect to it, and that'd actually probably be a varchar 250, because it's probably a GUID at that point. Right. So, okay. So we're running out of time. Does that make sense to everybody? Kind of like the ask here as far as like what the assignment is, and kind of like how to go about it. Really, the hard part you're going to struggle with is like putting this together. Because obviously, like I could do this, and this is actually probably, well, I've seen the back end, so I know it's fairly accurate, give or take some things. It's how it should have been built. But when you're doing it, don't worry too much about making sure it's accurate. Really, it's about what we want to happen here is to explore, to think about like the implications, like, oh, because when you actually start throwing it together, it becomes more complicated. Just like most people, when we started throwing this together, didn't think we'd have an order product table or a product category table. Usually we think in nouns, is objects, and don't think about, oh, there's an object that connects to objects, kind of a thing. Okay, so Nathan said you have to run, which is great. Just fine. The video is explaining this ERD table that we had already created from the website we chose. Yes, I believe so. If I'm understanding your question. Yeah, this is for week 2, and you choose a website. I just picked one that I would do just so I could walk through on, just to kind of give people an example of how to go about it.
Okay, but so we create this ERD table from whatever site we choose, and then we just kind of do the 5 to 10 minute video recording talking about this ERD table that we're going to make on our own.
Yep, absolutely. So
Okay.
now that I've done this, like take your best shot at it, and honestly, like I would kind of like put a time limit on it. Like this should not, you shouldn't be spending hours and hours and hours building this. Like I said, it doesn't need to be perfect. Take a stab at it. And when you kind of get there, like at this point, I would record my video and I would walk you through it, just kind of how I did as I was doing it, where I say, yeah, just walk through it.
Perfect. Thank you. I appreciate it. I apologize. I've got to bounce.
Oh no, yeah, jump. We're over time. So yep. Thanks for being here. Great. Does anyone else have any other questions? And is an additional note, if you're stuck, like if you like kind of get somewhere and you're just like stuck, like I said, I do not want you spending hours and hours and hours on this, like trying to get it right, because I really don't expect it to be right at this point. This is more an exercise in trying to start to wrap your head around, wow, there's like implications to how I design this database. That's really kind of the goal of this, and to start making you think like, oh, how would I connect these and yada, yada. So what I would say is if you get stuck and you're just like absolutely no idea, just shoot me a message real quick, send me a screenshot of what you got so far, and I can give you a real quick pointer and you can be on your way. So don't sit there stuck trying to brute force it for too long, because I can have you back up and running in a jiffy. So don't be afraid to ask for help. We are over time. So does anyone have any last questions?
Are you gonna post these like the last week recording?
Yes, yep, they'll always be recorded. As long as I remember to hit record, which is pretty rare that I don't, and nothing goes wrong, I'll always post a video.
Okay, thank you.
Yep. All righty. Well, if there's no other questions, I'll let you guys go. So thanks for being here. Good luck this week. And again, if you have any questions, just let me know.
Thank you.